All right, so basically last time we introduced the notion of a certificate. So you have Alice wants to talk to bank, let's say bank.com, and she needs the bank's public key in order to send, private communications. So she would like to say, give me, your public key. But as we saw last time, the problem is that there could be an attacker on the network that tries to, that will try to answer with an incorrect public key, a man-in-the-middle attacker. So instead, what we do is we use certificates. So basically, this bank has some public key B, has its corresponding secret key B, and is going to get a certificate from some CA, certificate authority, like VeriSign, for example, and that certificate is going to be a signature with the secret key of the CA, saying that the bank has public key B. So this public key B really belongs to the bank, and there's going to be some expiration date for this certificate. Okay, so this is going to be a certificate. And then the bank is going to send back this certificate along with public key for the bank to Alice. Okay, and Alice, you can assume that she has hard-coded the public key for the certificate authority, so has hard-coded PKCA, so she can verify SIG as well as expiry, and that it is for the bank. So namely, there's the bank's name in there. Okay? So if Alice trusts the certificate authority, such as in the case of VeriSign, then she knows that this public key is correct, and there's no way for an adversary on the network to have compromised this public key and serve a different one, because the attacker wouldn't have a certificate for that public key. Okay? Is this clear? All right. Great. And we saw that, last time we saw about a trusted directory, and this is better than the trusted directory for a few reasons. Anyone sees a reason why this is better than the trusted directory approach? Yes, everybody can serve the certificate. Exactly. So you don't need to contact the trusted directory to give you the public key for the bank. You can actually go directly to the bank and get the public key from the bank and not worry about the man in the middle, because really anyone can serve the certificate. So can contact bank, or really anyone who might have it, but bank, obviously, the bank is going to have its own public key to serve it, so that's a great place to go and ask for the public key. But then this certificate really helps you against man-in-the-middle attacks. To obtain PK, so you really don't. So in this case, this trusted CA would scale better than a trusted directory, because it doesn't have to be contacted every time someone needs a public key. Okay, so in that sense, it would be better. Also, it's better in the sense of reliability, because if this CA is down for an hour, maybe it's not so bad, because people can still fetch public keys and certificates from the respective people they want to talk to. And, okay, the CA can't issue a certificate within that hour, but maybe it's not so bad. But if for an hour people can't communicate, that's far worse. Okay, so it definitely improves the scalability problem. But there still remains a scalability problem. Does anyone see what that problem still is? Yeah? The CA can still be attacked, so that's a central point of attack problem, for sure, that still remains, and yeah. But how about scalability? Yeah? Yeah, so this CA has to store the public key of everybody, right? So that's really not scalable to have, every single individual on the internet the CA has to keep track of their public keys. That's really not scalable. So that's why certificate chains and hierarchies were introduced. Okay, so we're going to talk about that. So certificate hierarchies and chains. So the idea is that, let's say again, you have VeriSign, which is a CA, and then it doesn't just have everybody underneath it, but it has a tree underneath it, a hierarchy. Okay, so maybe there's the UC president underneath it. Maybe there's the Stanford president underneath it. And then within that, let's say there's David, and there's me. And right now, VeriSign only needs to store the public keys of the level directly underneath them. Okay, so only certifies level underneath, which is the president's. Okay? How? Well, it's going to sign with the secret key of the CA the fact that UC president has PKU, okay, and again some expiry. Now, the UC president himself or herself is going to certify the users underneath. Okay, so every single node certifies the node underneath. So you're going to have a signature using the secret key of the UC president, saying that David has PKD, and again some other expiry. Okay? So now when, for example, I contact David, what I'm going to receive is this chain of certificates along with David's public key, and I'm going to check each one of the certificates in the chain. Okay. So basically this is the certificate chain. And essentially it's a chain for this path, right? All right. So basically, when I talk to David, actually, let's say when I ask for his public key, that's better. So when I ask for David's PK, I'm going to receive, each certificate, so I'm going to receive C1 and C2. I will receive PK of David, but then also C1 and C2, and I'm going to check each one of the certificates. So also along with C1, I'm going to receive the public key of the UC president. Okay, so here's what I'm going to do. I'm going to check things recursively. First, I'm going to check the public key of the UC president using C2. Okay, so I'm going to look at C2. I have, using C1 here. Okay, using C1. So again, I have the secret key of the certificate authority of the public key of the certificate authority VeriSign hard-coded. So using the public key of the CA, which is hard-coded, again, it's always going to be the root is going to be hard-coded in some way or obtained through a different channel. And I'm going to check the certificate C1, right, which is basically using the secret key of the certificate authority is going to prove to me that I'm having the correct public key for the university, UC president. And in this way, I can actually check that this public key is correct. Then I'm going to, now that I know that this public key is correct, I'm going to be able to finally check David's public key using C2 and using the fact that I know what the PK of the UC president is. Okay? So this is how I recursively check a certificate chain.